So guys, welcome back, and let's continue with the next part. uh, so, uh, uh, Very important topic, and it is something like to properly design in the terms of performance or in the terms of cost also. Typically, more about the storage part. Okay, a lot of services, guys. Nowadays, now we know till date in AWS cloud, right? but uh, but having a proper plan, right, depends upon the use case to use case, need to need. Okay, we have a proper plan for costing perspective, and we have to proper plan in the performance perspective. Okay, so today's topic, guys, is again on the storage. And till date, guys, we have talked about S3 storage, EBS storage, EFS storage, and maybe some more storage we might have talked about. Okay, but we till date we have used, we have seen how to encrypt the storage, how to decrypt, how to store data, how to integrate, like, EBS with with EC2 or something like this, right? But uh, the most critical part, especially in the cloud world, to properly plan the performance part and the costing part of the storage. So very much core topic, very much important topic in terms of real world implementation also. If you want to use storage in the for the industry, and plus in the terms of management also, in the terms of costing planning, capacity planning, performance planning, or plus if you're planning for go for examination, right? These kind of questions, guys, they always ask you from associate level to all the professional and all the level of examination. This is a very common thing they always ask you in the terms of performance planning and other things. Okay, so what I mean by this very important topic, lots of concept we're going to discuss today. A lot of new vocabulary, guys, also gonna come up. Okay, but I would like to start the thing from very zero. So we are going to cover almost all the type of EBS storage. We are going to cover all the storage classes of S3. We are going to cover all the storage class of Glacier and where the Glacier fit. Okay, and plus we are going to cover the life cycle of S3 and their respective storage. Okay, or storage, and maybe some more small topic in the terms of planning or the storage or capacity planning the storage and something like this. So lots of things we are going to cover today. But to start any topic in the terms of, but all the topic would be more respect to costing planning and the storage and the capacity planning. But for this and before this, you should know some basics concepts. You should know some basic concept of this, of some of the terminology of the storage first. Okay, so let me start the things from very zero. Okay, but this is the guys agenda for today's, and I highly recommend to understand every concepts, right? Because it is not only apply on AWS cloud, it apply on all the cloud, plus any of the storage you use, it is very useful. Plus this concept is very much useful to planning databases also. Okay, and because of the performance, before of the performance issue, okay, that is a reason no SQL database being so much famous in the real world. Okay, so why we don't have to use RDBMS database instead of NoSQL, like we go for Cassandra, Graph databases. So it is purely the core. If you go to the core level, why we have to move to NoSQL databases, and slowly we're migrating a lot of workload in the NoSQL, maybe MongoDB, Cassandra, Redis, or maybe other databases. The core reason would be the performance. Okay, so today's class, guys, give you the motto and motive behind why you have to use NoSQL databases. Don't worry, guys, if you don't know NoSQL, that's okay. But today's is the concept class that give you all the concept related to storage in the terms of performance. Okay, so try to understand this topic from very basic, right? So let me start from here, and let me start in this in this context and in this way. Okay, so you guys know, if you have a data, and if you want your data to be processed by CPU, so you have to keep your data in your RAM memory or in your RAM. That's for sure, right? Because CPU will only read the data from the RAM. They won't go anywhere else as such. Okay, but only challenge in the RAM is volatile. After a system reboot, you lose your data, and that is the reason. If you want your data to be permanent, or is also known as persistent, you have to store data finally in the storage, because storage is one interesting thing storage provide to you is the persistent part. They make your data permanent. Okay, so this is a good thing about storage. But bad thing is about the storage. That's the main topic for today. Is storage is very slow. If you compare to RAM, maybe 10 times, 100 times slow they are. It means, it means if you have some program running, and program need, and the program your function running, a function need or algorithm need to run. Obviously, CPU is the one who will run your function or the program, but that program need a data, and data is there in the storage. Okay, and if data is there in the storage, till the data come to CPU won't able to do anything. So CPU will wait for data to come to CPU, and CPU, because always read the data from the RAM. So technically, you have to load, or you have to transfer the data from the storage to the RAM. Okay, and after the data is stored in the RAM, then CPU read the data and do whatever processing they would like to do. Okay, so technically, CPU is super fast, no doubt. RAM is super fast, no doubt. Okay, but because if the storage is slow, if the storage is slow, so it takes a lot of time to read the data from the storage and send it to the RAM. Okay, and after then only CPU can do the things. So my point, guys, over here is, if let's say the CPU work with the speed of 100, let's say RAM also work with the speed of 100, and if the storage work with the speed of 40, okay, so there's no good reason, right, to have this much bigger CPU or this powerful RAM. Because overall, because if CPU depend on the data and your program is depend on the data, and data is coming from storage slow, so overall process would be slow. Okay, so it's like bottle. So this is your bottle, right? There's your bigger size in bottom, but if you in the top you have a smaller size of the bottle, so overall speed that liquid come out from the bottle or go in the bottle with the speed of this one. So this size doesn't matter. The size does matter. Who will decide the speed of liquid go in and come out? Okay, so that is the reason, guys. This is known as bottleneck. Okay, so that same terminology we use in this kind of world. CPU is super fast, RAM is super fast, and because the storage is slow, and my program that's run by CPU and RAM is depend on the data that is then the storage, so overall system will be slow. So technically, our storage is always known as the bottleneck. Okay, or I can say storage will impact the performance of overall system. So that's what called the planning, guys, over here is. Okay, so how can you make storage perform well, or perform well, or how can you increase the speed of the storage? That's the whole and soul motto for for today's discussion. Okay, and here we have to use lots of things. We have to use some management techniques. We have to use some kind of different flavor of the storage. Might have to invest some extra money. Multiple things we have to club together that will finally help you to get and reach to the final solution. Okay, so what I'm talking about, let me start from very basics again. But one more terminology I want to tell you here is, okay, here is 1 minute. Guys, 1 minute, please. I don't know why am I this screen was minimizing. 1 minute, please. Okay. So there's one small terminology I want to discuss here. If you have a storage, okay, and from the storage, if you want to write any data or read any data, there's two main things obviously you will do. Okay, and this guys is called IO operation, input and output operation. So when I use the word IO, it normally mean to say storage. Okay. Now, the point over here is, right, in the storage, how well you are managing your write. Okay. What I mean by this? Okay. Let's say storage say this is your hard disk, and hard disk say whatever data you store here, the speed that you can write or speed that you can read, let's say is 10. There's no unit as I'm just talking about 10. 10 is a unit, means let's say CPU is working with the speed of 100. Let's say they run with the 100 kilometer per hour speed, and let's say hard disk run with the speed of 10 kilometer per hour. So just think in this way right now. So let's say hard disk work with this speed. Okay. So now point over here is if you if you want that whatever data you want to read in the future, and who want to read, obviously your program or CPU want to read, and how quickly you read, that always matter a lot in the terms of performance of your CPU and performance of your program. Okay, and why we want things to be faster? Because we know we live in the agile world. I want what out of program we are over here. They will retrieve the data faster, so that my program will run faster. If program run faster, so overall output will come faster. And that's what we need everywhere in the today's world. So I want everything to be faster. Okay, so so my point, guys, over here is, if you want your read to be faster, means your your output as a hard disk perspective is for IO, your output of IO is so faster. So it is purely depend upon your input. Means while writing the data on the hard disk, how well you arrange your data, how well you organize and manage your data. Okay, that's also impact a lot. Guys, there's a lots of huge discussion in this topic. Obviously, I don't want to go in the direction right now, but okay, but just think in this way: how well you organize your data and how well you manage the data in the hard disk. Okay, for example, just very high level example. Let's say if you have a file, okay, and let's say this file size is 1 GB in size, and we know according to our requirement, whenever we need this file, we always read this file either completely or don't don't read, or maybe you download this file from the hard disk, either entire 1 GB or maybe we don't read some of the part. You know, sometimes we open the file for 1 or 2 pages. So let's say we have a requirement and we want the future requirement would be what a file we have. Maybe this file is a data, and this data contain your complete data, and normally this is called data set. And normally this data set is used by some your analytics guys or reporting guys, and what they do, they come to this file and read all the data from this file and put in the reporting system, so that they can they analyze the data, they can create a graph and something like this. Okay, so let's say this is the requirement you have. Okay, or maybe I can use if you have a data that is more useful for analytics perspective or analysis perspective, or let's say this file is bigger in size, so I maybe can use the word called big data. So let's say we have big data kind of file with you, or huge data file with you. And normally in this world, whatever file we have, we always read fully, so that, because I want to create a report fully. Okay, so how faster you can retrieve the file from the hard disk, that matter a lot. Okay, so what can we do? What normally we can plan it, right? Because you guys know, whenever you want to store the data in the hard disk, okay, I'm talking about typical older kind of hard disk that is normally known as magnetic hard disk. Okay, I'm talking more about magnetic hard disk. So if you open the hard disk, so normally Intel hard disk, they have lots of platter. I'm talking physical platter of aluminum or some material, and every platter is divided into multiple tracks, and every track they have some small portion that's called sector, and finally here is the one we store the data. And typically the sector size is 512 bytes. So you want to store 1 byte or 500 byte, they consume whole 512 bytes. Okay, and normally OS to OS, okay, so this is the physical sector I'm talking about, is there in your hard disk. But whatever OS you're using, maybe Red Hat Linux or Windows or Mac, they decide, okay, what are data they want to store in the hard disk. So at one point in time, they will pick 2 sector together, or maybe there's a I pick 4 sector together. So depending on OS to OS, let's say my Red Hat Linux say in one single maybe I want to I want to store one data or want to maybe 1 byte data, or want to read 4 byte data. In any of the cases, I go to my hard disk and in one go I will read 8 sector together. Means 8 sector means, if you try to calculate 8 into 512, it means 4 bytes. So guys, it's OS to OS to vary again, because they want to improve the performance, because they believe if somebody want to read some data, nobody obviously want to read 1 byte, 2 byte. They have planning to go further and read further byte also. To better to have a proper organized way, just read block of 8 sector or 2 sector. Every OS to OS is very, we can also change if you want. But typically in the Red Hat Linux, okay, by default they read 4 byte or 8 sector together in one go. This is OS perspective. Every OS we have a different, and by saying this is called one block. So typically one block size in your Red Hat system or Linux system is normally 4 byte in size. So it means if I very quickly open my Linux OS also to show you and the proof you, this is what is happening. Okay, so you will see, but you can change it. That's the point, right? The different point. So technically what I'm talking about, so let's say this is your hard disk and this is your one block. Again, that's one thing, one block here is 4 byte. The second block, third block, fourth block, and 5 block. Okay, and because this first block contain what? Internal physical 512 bytes of one sector, means 8 sector, the 8 sector, the 8 sector. So it is a continuous address, continuous address in the hard disk. So what normally we do, and that's one thing, guys, if you go for mechanical hard disk, okay, so in the top of this platter we have some head, right? It's like a spindle. They keep on moving with a speed of something like maybe 7200 RPM. With some speed they're moving, and they keep on moving, let's say in this direction. And if your data is continuous in the hard disk, so this spindle or this head is the one who's keep on reading the data in some 010 format or some kind of Hall format. Okay, so if your data is well organized and this data is continuous in every sector, in every block, so reading the data okay, after you write, because you write in the same order or in the continuous order, so reading would be super fast. But if you store a 1 GB file and some data of this file is stored here, some data of the file is stored here, some data file is stored here, and somehow we link it. There's a different point. So if in this case, if your header in your hard disk want to read one single file, first they have to move, reach here, then again they move. They can't jump because the physical header on the top of your hard disk, they can't directly jump to other position, or they can't randomly go to any other position. Okay, they have to completely rotate, and then after some certain distance they find next data. Okay, so understand one thing, if you arrange your data in very random order, speed of reading reading this data would be obviously very slow. But if your data is a continuous in the hard disk, in your physical sector, or in the arrange in the continuous block, so if you have this kind of arrangement, so reading of this kind of data is always super fast. But only drawback in this situation we have is, normally it is not always possible that we always get a continuous space of 1 GB or 10 GB or 10 terabyte, depend upon the size of file, because it is big data, file size may be very much vary. So what can we do? We can properly, if we have a use case where I want to store our raw data, big data, data for reporting, data for analysis, analytics. Okay, if this kind of use cases if you have, so what can do from wherever, guys, we getting the storage, we're asking their storage program, typically known as driver, who finally connect your OS to the hard disk, and also OS to the storage, and say try to arrange all the file, because finally in this storage where we are using this storage for one purpose to storing big data or any file that is bigger in size normally. So I want try to arrange this file in such a way so they will store continuously. If they store continuously, it means we arrange the data continuously. Okay, arrange the data continuously. So next time if you want to read this, so reading the speed would be speed. We can't change the hardest speed. Let's say hardest speed is fixed. But let's say my hardest speed of reading data, there's a spindle running there. Let's say they run with 7,200 RPM. This is speed they're running. So this is a physical speed. Let's say in this hard disk, we can't change the speed, for example. But if you properly arrange the data in by this kind of particular design, for example, so so reading will be faster, and that's what we want. Because normally write we want do once, but while writing, if you arrange properly, next time if you keep on reading, keep on reading, it will be faster. Okay, so if you have a use case like this, if your use case like this, that we want to store big data normally, or big file normally, or normally known as filers or NFS server, there normally we have big files. So we always ask to have this kind of storage that internally manage my storage in this format. Okay, and if this is the case, okay, so this kind of hard disk, we always talk about the hard disk speed in the terms of throughput. So if you store your data in the hard disk, you store a file in the hard disk, okay, and if you want to ask the speed of this hard disk in terms of read and write, especially in terms of read normally, okay, so we say because my data of this particular file, I want to read this file, my reporting system want to read this file. Okay, so so because my file is continuous, so my internal physical header is keep on moving with their speed. I can't change the speed. Okay, but because data of the file is continuous, so I can very quickly find all of my data of the file because they are in the continuous, so my speed improve, or I can say my throughput improve. So this kind of planning or getting the storage, I can say my hard disk is optimized for throughput. This is the term we normally use. And how much data you read? So normally, guys, we always say per second. So per second, how much data you can read? Again, it purely vary upon the speed of your physical spindle that is moving, or physical head that is moving. That you can't change. But here we are optimizedly use the actual speed of the hard disk because my data is continuous. So let's say because of this physical speed, maybe I might getting 40 MB or MIB data per second. So if we talk about my read or maybe IO, let's say both input and output speed, or the better would be my throughput would be 400 or 40 Mbps or megabyte per second. It means because my data arranges continuously, in 1 second 40 MB data I can read very quickly. So my point, guys, here is if you have a use case where you think you have bigger file and normally you have to read entire file, or you don't want to read entire file, this is the normal case you have, especially in big data or analytics world. So ask for the vendor or ask for the cloud guys, do you have any hard disk that plan my storage? Okay, and where we talk about the speed in the terms of throughput, because my plan is not to read random data. My plan is to read the data with some speed, means continuously. So there, guys, we talk about throughput. So if you go, and guys, you know one thing, if you talk a hard disk, okay, if you go to AWS and you ask, do you have any hard disk, okay, where we can store the file? And normally, guys, when we talk about hard disk, it is always known as block storage. And if you go to block storage, then we have EBS as a service, elastic block storage. So if you ask EBS, do you have any hard disk that give me, that we can calculate, that we talk about a file that is bigger in size, that will solve the use case of bigger files, all right, or there I can calculate my speed in the terms of throughput. So they say yes, we have those kind of hard disks. So so if you guys search here, 1 minute, if you search here in AWS EBS throughput kind of storage or hard disk, okay, or throughput optimized storage, you will find some volume types. Okay, and there's some kind of hard disk in the EBS, okay, that has been optimized for throughput kind of thing. Okay, so these are the hard disk. If I show you in the in somewhere, okay, throughput something. So these are the hard disk that is optimized for throughput. Okay, that has an intensive workload. Typically, here mean to say bigger size in file. There we have more and more. So throughput, as really since here, is so much optimized for this kind of workload. And some other use case also they have. So there's two different hard disks available. Okay, so if your use case is big data warehouse, again like a big file only, and normally you have log file, a huge log file. Typically, not always we want to read a log file, but maybe you want to do some log analysis. That way I want to retrieve all the file and try to do it. So I want my all the log file will store in continuously. So log processing. So there's one volume type called HT1 is available that will do this kind of log size, use case this solve. Okay, and their throughput speed per volume is this much. So if you get one hard disk of type HT1 from EBS, okay, so maximum throughput that you can get in the hard disk is in 1 second 500 MB they transfer. This is huge, right? They transfer. Okay, but the challenge here is if you go for this one hard disk, they are comparatively a little bit higher in price. But if you want to have a same facility, but you want to go for a little bit cheap solution, then you go for cold HDD. The name is SC1. Okay, only difference is you will get a lesser speed. But if you think it's okay for you, you don't, that reporting that you're doing is not so much important right now. If you done in 1 second or 10 second or 1 minute, that will be okay for you. So you can go for a little bit slower speed. Okay, only difference is, okay, they will lower the cost and they will lower the huge cost. But technically, internal perspective, okay, they are talking about throughput. They are reading data continuously, and the most important thing is the big difference here is the price. Otherwise, if you talk about durability, is also same. Failure rate is also same. Okay, but this kind of hard disk normally we use for those data is very infrequently used. So if you bigger file, but you think you don't want to use so much frequently, if you even want to use frequently, but its speed might not be so much impact here, so then you can go for this one. So otherwise, you can see almost everything is same. On speed will be just half. Is if you talk about bigger picture, it's very much lesser actually compared to this one. Okay, but they are comparatively very cheap in price. So somewhere you might see price is also available. Okay, this is, guys, the meaning of throughput, and this is these are the use cases we solve. So if you guys do any Hadoop kind of practical or big data kind of practical or data warehouse kind of implementation kind of use case, if you have in AWS, so they always recommend to choose these hard disks. You can change it to different hard disks. That's called IOPS hard disk. What is IOPS? We'll discuss in a minute. But they recommend to that they said this hard disk is optimized for this kind of workload or this kind of use cases. So better select this hard disk. Okay, that's what the meaning of this hard disk is. So what is IOPS? That is my next topic. We'll discuss in a minute. But this is the hard disk. So let me show you very quickly to my AWS portal also where you can get this hard disk. Okay. So by the meantime, I also log into my Linux system. And something like this, guys, if you was with me in my RSCSA training, that is again the free classes and ISA Rise, in my partisan classes, if you was there, I have also a little bit talk about this internal sectors, how they work, how they store the data. That was very much basic. If you want to see at that level also, internal level also, how the thing work, I suggest go to that videos in the IIC Rise channel, and you come to know what is going on. So for example, this is my system. And if you talk about this system, okay, and if you run the command called fdisk-l, it will tell you all the hard disks that I have. Okay, and if you talk about the main hard disk is this one, the storage size is 100 GB in size, and one sector of this physical hard disk is 512. So my data is stored in my hard disk physically, and they use 512 byte sector, okay, in the physical hard disk. But this is hard disk perspective. But as OS perspective, they they I don't know, guys, have you noticed this point or not? Let me ask you guys, tell you one interesting fact about Linux. So I'm creating one folder here. Okay, in this folder, if you do ls1l, you can see, guys, you see this number is 0 here. Okay, and what I'm going to do here, I'm going to create a one file with some data. Okay, so I created this file. Now you know what happened, guys. This number changed to 4. Okay, so what do you mean 4? But let me, guys, again open this file and let me store some more data. And you can see, guys, the size of file data is changed, but the 4 is again the same. Let me increase my data more. Again, the file size changed, but this total is 4 is same. Okay, you know what I mean by this 4? Okay, right now, what is OS is saying? This OS is saying, okay, finally your file data is stored this much in physically in the sector, that is 15112 byte in size. But whenever I create any file, okay, this file we provided 4 blocks in one go. So we allocate 4 block continuously to you in the hard disk. So whatever data you will add in the future, this data will be continuously stored in this 4 block in the hard disk. That's all. But after 4 block data save completely or consume completely, then I will provide one more 4 block size. So I will give the size in multiple 4 block. And what is my block size currently in this system? So there's one command called, guys, get conf command Linux. And if you search for block size, so it may be 1 KB or maybe is get conf a, and it is what is the is it's not piece size. Some command is there. So maybe some, I don't know, I maybe forgot. It's not get conf, but some command is there. I think get conf is some option they have. So you'll see, guys, what is your final block set. Okay, maybe IO something. So I just missed out. Maybe I thought get conf is actually page size they're talking about. So the one command just for is space from my mind. Okay, but you can see, I feel in this OS, but block size will be 1 kilobyte, and they give 4 kilobyte in size, and they fix it so that they can have a continue. So my overall plan, guys, point would be here is I think block dev is a command, I believe. So in the block dev, if you go for help, and here they here so they have a command to tell you the size of the byte. And so, like, this is the command. I think some options there, so just go and figure out. There's a block size I'm talking about. Okay, so this command is one who will tell you what is your current block size that OS is provided. But technically there's a different point altogether. Okay, my main point here is to make you understand is okay, it's all about arrangement of your data, or arrangement the internal continuous memory of the data. So if your use case is 1 minute, if your 1 minute, please. So if your use case is you want to store continuously data, especially in bigger file, and you want to read all the bigger files continuously, then try to arrange your data continuously and ask the storage driver or the OS or the type of hard disk that try to give me a continuous storage. And these kind of hard disks, if they give you a continuous storage, they always talk about the speed in the terms of throughput. Okay, throughput is a term they use for the speed. Okay, and that's what I'm going to show you. So I go to EC2 portal, and here we have a volume called EBS. You guys know how to create the volume. And if I create a volume, here they talk about the type. Okay, and if you go to GP2 types here, there's by default there is no throughput applicable. So what is GPU type? They work in a very different concept called IOPS. What is IOPS? We'll discuss in a minute. So either your hard disk work in IOPS concept or they work in throughput concept. Either one, technically, right? So what is IOPS? We'll discuss in a minute. So guys, it's not IO. IO is different thing. It's input output. IOPS is different thing. What is this? We'll discuss. Okay. So this hard disk is not applicable. So there's 2 hard disks. One is this one and this one. So according to the document, there's 2 hard disks who give a capability to store your data continuously, and they talk about talk about have solved the use case of big data kind of thing. Okay, so if I go for this one, then here you see throughput option automatic come, and maybe if you go to this one, sorry, this one throughput option gonna come up. Okay, and understand one more thing here. If I go to hard disk SC1, and let's say if I go for the hard disk size of 1000 GB, okay, first of all, guys, in this type, they won't allow you to have less than 150, 125 GB size. Maximum this much size they allow. You can't create less than this one. This is one thing. And second thing is, okay, they say if you use 1000 GB hard disk, I will give you a speed of 12 Mbps. This is big GB. Maximum that I support is 79. Okay, but if you go purchase 1000 GB hard disk, I will only give you 12 Mbps speed. Okay, but you want to increase your speed. For this, you have to buy bigger hard disk from me. So if I go for 10,000 GB hard disk, you can see, guys, if I increase the hard disk size, okay, they increase my throughput. So guys, here this is the way they are selling, or this is the way they are managing. There's some physical reason also for this. I'm not moving to this part, but if you think that, for example, if you go for 125 GB hard disk, there's a minimum one they support. Okay, so only speed that you get is 12 Mbps per terabyte. If you increase this, okay, so this much throughput will get it. Okay, this baseline is a different point. What is baseline we might discuss, but this much speed you are getting. Okay, this is one thing. But if you go for a different hard disk called throughput optimized one, you can see, guys, your baseline will change. So you can think baseline, just think it is minimum you always get. But there's some kind of credit, something we might discuss. So there's a minimum you get. So throughput will give you the speed. Okay, and if you go to maximum size of hard disk that you can purchase in one go, is this one, 16384. Okay, so maximum throughput you can avail from the from this guy is this much, 500 Mbps, and that's what, guys, they're claiming in the document. So maximum you can claim is 500. It doesn't means sorry, that always you get 500. Okay, if you purchase hard disk with the full size, then only get it. If you go for lower one, your throughput will decrease. Okay, there's the one small point, just keep in mind. Okay, and lesser you invest, lesser size you go, lesser the throughput. Why the way it is being managed by driver and some other performance tuning in the storage they have done, there's a different point, but just keep in that in mind. So if you want to have more throughput, bigger speed, and also read and write IO, then go for bigger size in hard disk. Obviously you have to invest more. So there's one thing, right? And only two hard disks you have where you can plan for the storage. Okay, but there's one more concept, guys. This is called IOPS. So what is IOPS? Okay, so let me explain one more use case. Okay, and let's say you want to store in a hard disk a database. Okay, or maybe in the hard disk you want to send store the mails. Okay, so if you talk about mail, every mail you get, let's say every mail is one single file. And if you talk about the one single mail, maybe one file, maybe 1 kilobyte. Or let's say one single account every day get 100 mails. With 10,000 employees in the company, hundreds of millions of mail every day you get. So this much bigger file size you have, only bigger 1 kilobyte files. Okay, so let's say this is one single hard disk where all the mail file or mail is stored for of all the employees. So one mail file is stored here, one mail file is stored here, one here, and everything, let's say, is 1 kilobyte in size, or one block they consume, let's say. Okay, one block or 4 block. I told you by default they give you 4 block in one single go, but let's say 1 block you consume. So your mail stored here, other mail stored here, other mail stored here. So maybe there might possibility this is one single hard disk or one centralized hard disk. Let's say we have employee A, employee B, employee C. This guy also want to read a mail. Same time, this also want to read a mail. Same time, this guy also want to read a mail. And because if you want to read the mail or want to retrieve the mail, you have physical header on your hard disk, and they will go physically there in the hard disk, retrieve the data and provide to you. Okay. Now point over here is if this header is busy to retrieve this mail, same time if B asks you to read the mail, and same time C or D or 100 more employees ask to read the mail. Okay. So this header might not go to this person or next person at the same point in time. Okay. So we want such a hard disk. Okay. First of all, we don't need this kind of typical solution like a magnetic kind of hard disk. Okay. I want a solution where at one single point in time, I can go to multiple processes in together. Or one single point in time means 1 second, in 1 second or one point in time, I can go to multiple location in parallel. Okay, and a multiple operation I can do. Maybe somebody also asking me to write the mail or update the mail or change some data. So same time I can go for input, same point in time I can go for output. But at the same time, I want to do multiple operation of read and write in multiple location, or I can send random location. And this is the case normally happen when you have lots of file, hundreds and billions of file, smaller size in file. It may mail file or maybe databases also. Because guys, when a database you have, so you have a lot of rows, a lot of column. Some of the rows stored here, some of the column is stored here, some of the column is stored here. Somebody adding the file, somebody reading the file for your data from the databases. So same time, a lot of guys are reading and writing. Okay, so I want such a optimized hard disk these are so much optimized for random reads or random writes. Okay, so these kind of hard disks we need, and typically this kind of hard disk in the market come with the name SSD, solid state drive. So right now, guys, nowadays SSD very well. So normally, guys, now our laptop come normally with SSD. That is the reason my laptop boot very faster. I can copy data very faster because at the same point in time, lot of process running in my laptop. Everybody can read from multiple locations, write multiple locations. So it makes my CPU and RAM faster because they don't have to wait much time to read and write the data from the hard disk. Okay, so I want such a hard disk that has capability to randomly go to multiple locations and read and write data together. But how you calculate the speed of these guys? So we calculate the speed of these guys in 1 second. In 1 second, in 1 second, how much operation of input output they can do. And guys, this is called IOPS, input output per second. So this kind of hard disk is normally calculated with a unit called IOPS. So we can say my hard disk can read 1000 IOPS. It means in 1 second, 1000 read and write operation they can do in multiple locations. Okay, so, but this kind of hard disk, guys, is not good for use for big data, because at big data, guys, we have single file. Okay, and I know my pointer has to keep on reading the data continuously. So there's no meaning I want to read my one file initially and middle, then middle. I want my file to be read continuously. There's no meaning to read the file randomly. So bigger file, this kind of hard disk is not useful. But if you have smaller files, lot of files, millions and billion file database you have where you want to randomly go here and there. So this kind of use cases, right? The hard disk that has SSD or hard SA type, and that hard disk where we calculate the speed with the terms of IOPS, means input output per second. That makes more sense. Okay, and that easy reason. So if you ask again Amazon, do you have any hard disk that is optimized for random read and write that work in IOPS, right? So they say yes, we have some solid drives. Okay, they are very much for is a different thing. They're for mission critical, all the things. But technically, if they use the word IOPS, it normally mean to say IOPS is a general concept of in the storage world. It normally mean to say they have a power of randomly read from here and there. Okay, with the speed depend, right? So they have a speed of 1000, 10,000. That's matter a lot. And that's what, guys, Amazon is selling these hard disks. Okay, so if you ask Amazon that I want 100 GB hard disk, okay, so they say normally, guys, this is a typical way. So Amazon is selling, guys, they say if you buy 1 GB hard disk, I give you 3 IOPS. This is a typical way they're selling. So if you need 300 IOPS, then you have to buy 100 GB hard disk. If you want 3000 IOPS, you have to buy 1000 GB hard disk. So this way, guys, there's selling model is okay, business model is, so how much speed you want, that much hard disk size you have to purchase from this guy. But why want more speed? Depend upon data, right? If obviously, guys, if you think your business very important, you have a database and thousands customers connecting, they want to read their post, their profile, they want to update something in the profile. Obviously you don't want your customer to read. You might have a great CPU, great internet network, a great RAM, but if hard disk read and write is so slow, there is a bottleneck always, overall it will impact the performance of this of a customer. So for this system or this hard disk or this data that you store in the hard disk or my database is very critical, is a business critical applications. So there, if you want to have more speed, this is called more IOPS, you buy bigger size hard disk from the AWS. And guys, typically they sell GP kind of hard disk. It's called GP2 SSD, and this is a very typical hard disk they always sell to us. So if you go to GP2, here there's no meaning of throughput, and here they talk about IOPS, and they say we always give 3 IOPS per GB because you purchase 500, so into 3, 1500 IOPS we give. But if you go for 1000, okay, so this is a maximum IOPS I support in G2. This type hard disk I support maximum this. You can go for 1 GB also. This much hard disk size also. If you increase my hard disk size again to 10,000, okay, your IOPS will increase. For some reason, this concept called burst. There's a different point, but typically the maximum IOPS that we support for this one. Let me show you again for this much size. So what is burstable? We'll discuss in a minute. What is burstable here? Okay. So this is one thing. So in this type of hard disk, if you again go to document, in this kind of hard disk, okay, the maximum IOPS they support actually nowadays, this one, they haven't updated there. So by chance they support this one. So let me increase, let's say 16384. So guys, not 3000 actually, it is the maximum this one support. Okay, so maximum IOPS they support is this one in this hard disk. So this is the maximum speed, guys, you can get. Okay, either purchase this hard disk, or maybe if you go to 16,000 also, I think there also time also you reach to this person. Or let me go for 1300 also, again this is same. So because it's multiple 3, so some number above, your speed won't increase. So maximum speed of IOPS that support in GP2 is this one. But if you have some mission critical application that require a lot of speed of read and write of data, because millions of customers reading and writing from the same hard disk, maybe, okay, then you have to go for a provision IOPS, right? So this is second hard disk you have to provide. It's called provision IOPS IO1. Okay, there you can reach 64,000 IOPS per second. Is a great one. That much IOPS you can reach. Technically, I'm talking about this one. IOPS 1. Here you can go for maximum this one. By the time they have one more version 2, 2,56,000 is huge. Obviously, they come with a huge price. Okay, but this much IOPS you can get. And obviously, guys, if you read and write faster, obviously your throughput will increase. But throughput always doesn't mean continuous. Throughput means with the speed you can read and write the data. Okay, so if you go for this much IOPS, means this much operation you can do per second. Obviously, you can go for this much speed of read and write of your data per volume basis. Okay, and this hard disk is for workload, database workload that we're talking about, and this kind of hard disk is for mission critical application. If you go to provision one. Okay, so is so my main point, guys, here to understand is, right, is it's not like randomly we have to select any hard disk. Okay, first we have to think about what kind of data we want to store. Small files is database. We have to go for SSD hard disk. Okay, is a big file, big data, endless purpose, go for throughput. This one. But if the file that we have is going to consume and use with a very high speed, maybe your production system you have, then go for this one maybe. And here, because you can increase this much IOPS. For example, if I go for 10,000, okay, and I want to increase my IOPS to 3,000 or 30,000, I can go. So here we have a control on changing the IOPS. Minimum, you can go for this one. Minimum size of hard disk, you can go for this one, but you can control the size. But obviously, guys, they come with a huge price. So you can go here somewhere. They will talk about the pricing also, right? So obviously, they come with the huge price. Okay, but here my main motto is to explain you the type of the hard disk. So in the top, whatever you have, they work on IOPS concept in the terms of measurement. These guys are your HDD hard disk, continuous. They talk about throughput, and this is an older one, magnetic. In older laptops we have a SATA kind of hard disk, something like this. So these are the older ones. So there's no meaning of IOPS and all this. So it's outdated. We can think in this way. So might not be so much useful. This hard disk. Okay, this is one thing. Now GP2 is very commonly used, general purpose, because they can have capability to read data randomly, but with some limited speed. So they will not charge. They are not so much costly in the price. And that easy reason, guys, whenever you launch any instances on EC2, so by default hard disk, that is a boot hard disk, is always be used as GP2. So guys, when you launch any instances, have you ever noticed when we attach any hard disk, okay, and while launching the storage, next one, we always use GP2. They give you this much IO speed. So for boot volume or the root volume, this much hard disk size and speed, sorry, not size, I'm talking the speed would be very much enough. Okay, this is one thing. But the guys, interesting fact about this kind of hard disk where you have the IOPS, right, is concept of burstable. This is a very interesting concept Amazon provide to you. So it is something like this. What is burstable? All right, let me create a graph, and let's say this is the time graph versus IOPS graph. Okay, and for example, I'll go for this hard disk, and this hard disk give me 100 IOPS with this, or maybe let me go for this page, and let me I'm going for a hard disk of 1000 GB, or let me go for 100, for example. Okay, in this hard disk, because I purchased 100 GB into 3, in especially GP2 into 3 per GB they're giving me. So 300 IOPS they give me. Means 300 operations per second randomly I can do in the hard disk. That's my speed I can get. Okay. Now, so let's say this is 300. So this is my baseline. 300 IOPS I can get every second. Okay, so every point in time I get 300 hard disks. Okay, so now what happened, guys, here is so this is called baseline. Maybe let's say this first, second, third, fourth, fifth, sixth, seventh, eighth, 9, and 10. There might be possibility when you start using the hard disk, initially, let's say initially you use only 100 IOPS, then you use 200 IOPS, then you use 50 IOPS, then you use some IOPS. So you always be less, for example, till 10 seconds. So if you try to draw the graph till this second, this time, this one, if you try to minus this, obviously these are the number of IOPS has been left. For example, if we talk about this point in time, let's say 2 seconds. Okay, the maximum IOPS you use is 200 and baseline is 300. So 300 minus 200. Okay, 100 you can use more. That is allowed to you. It's free to you because you're in this model. You already purchased this much IOPS, but 100 is unused. Let's go for this time. Let's say 4 minutes. Let's say 50 and total you can use 300. So 300 by 50 is 250. 250 unused. So if you try to calculate this area, if you try to calculate this one, let's say 2000 IOPS, it is unused by you or it's not used by you. Okay. So in this case, what happened? Amazon, it is like a credit. It's like credit note. So Amazon will store this thing in somewhere in the box. It's called bucket, for example. Okay. And this bucket is called burst bucket. And what they do, they say, I memorize this information for you. Okay. And I'm reserving this much IOPS for you as a credit note. So this is your credit in my bucket. Whenever you want to use in the future, you can use. So there might possibility, guys, maybe after some seconds, some minute, suddenly we have a spike in the traffic. A lot of guys start using, and maybe suddenly you want to use more than 300 IOPS. So maybe let's say 1000 IOPS you want to use. But according to a hard disk, you can't use more than 300. They stop you there. It means they slow down. They slow down your speed, right? But before they slow down, they see in your bucket 2000 credit is left. Okay, so without any charge, without slowdown, okay, they provide this credit, so you can at the time of spike, you can use more IOPS. So the guys, this concept called burst. So you can burst then more than your baseline. So maximum you can use this one free, or they will allow you to go maximum this in totality. Okay, and again you go down. Again you reserve or add more credit in the bucket, and again you burst. So this is again a great benefit. Technically, what I mean say, whatever we are charging you, that my IOPS, the speed, we will provide you. If you don't use, don't worry. Somewhere when the spike come up, when you need more credit, I will provide to you. Okay. Maximum burst level that I can allow you is 3000 IOPS. So you can't go above 3000 because this hard disk at that kind of size, we don't support more than this. Okay, more than means you can't go above 3000. If your total credit 6000, 3000 IOPS maximum we allow, but you can keep on using till your credit being exhausted. So this is the meaning of burstable. In this IOPS hard disk they provide to you. If I go for 1000, so we already reached 1000. Okay, and again same concept will apply here. Okay, so guys, this is the meaning of burstable, and this is the meaning of credit over here. And that is the reason, guys. Maybe if you go to any hard disk, okay, any hard disk, and if you see in the hard disk, if you click on the monitoring, okay, here guys, they talk about throughput, the read and write speed. Okay, and here maybe not in this graph, we can customize the graph, and we go to CloudWatch. There you can go and they talk about how much burstable you go, and how much credit you have, how much credit you use. So some more graph you can customize in the CloudWatch. We'll see, guys, about CloudWatch. So there are a lot of metrics for this part also. Okay, so this is one thing. So technically, guys, based upon the use case, Amazon has, guys, planned multiple different kind of type of storage. In the block storage I'm talking about, S3, we have a different plan, block storage, and this is the great document where you can see the use cases, what different kind of hard disk they have, depend on the workload. Okay, workload, we have different hard disks, the speed and the performance. The two common terms that everybody always confused, one is throughput, one is IOPS, that I explained to you already. Okay, now based upon this information, you can plan your capacity, and accordingly you can plan your cost also. if you think, right, by some, normally guys, when you put the application, we do a testing on the application, regress testing on the storage. You normally come to know what normally IOPS and speed and size we require. Okay, so you can accordingly plan. You think now we don't have a lot of customer come up. Okay, let's go for GP2. But my file size is smaller. I need random reads and writes. So let's go for GP2. But this is business critical application. I don't want to any kind of risk. I want to take I have a huge client base. Okay, so let's go for IO2. But obviously you have to invest more. But if you have less client, if your data is continuous, having this hard disk is not a right decision, right? Because it will give you speed, no doubt. It will give you throughput, no doubt. It can store big data file here, no doubt, but it comes with a huge cost. Okay, so we have to manage the cost also here while doing capacity planning. So we can better go for these hard disks or maybe this hard disk, depend upon requirement and the workload. Okay, so that's the point. Otherwise, creating this hard disk is not big deal, guys. You know how to create the hard disk, put in one AG, create a snapshot, do the encryption. Everything is same, attached with the EC2 storage. Everything is same, but this part is very important in the terms of cost and the performance and the capacity plan. And this document that I opened right now is very much useful. All the core concepts I already explained to you. Now you can use this concept, read this document, and accordingly plan according to use case. Two use case I already talked about. This is very majorly use case. Small file databases with one use case, and big data analytics is a different use case. Okay, so that is, guys, about EBS. Now something similar, we have a concept on S3. I know I believe everybody know S3. Again, this is storage, permanent storage, but this storage we use to store the objects. Okay, we put the one object and every object is independent, and that is the reason, guys, this is known as this is known as object storage. Okay, so let's talk about, guys, S3 as a whole. Okay, so technically if you go to S3, so guys, understand one thing. Let's talk about one small scenario. Okay, let's say you are a bank and you want to store the data or the information about your customer. Okay, and normally, guys, this data, whatever we store, okay, let's say bank store every day all the customer, all the transaction they have done. Okay, not the transaction, this is the different example might come up. Let's say in whole day activity, whatever they do, how much business they're done, total customer come, loan account and credit account. So let's say these are the information they have. And let's say today's 3rd of April. Okay, so what they do, they create one file with today's name, let's say 3rd April .csv file, for example, and this is one single file, individual file for today only, and today's unique day in the entire, if you talk about time perspective. Okay, and they store this file in S3, obviously in some bucket. And let's say the bucket name is we create a bucket name called bank. So bank is a one bucket we create and we store here. Okay, this file. Next day in 4th April, same thing happened. We create the 4th April CSV file. Again, we store in the bucket called bank. Same thing we keep moving. Okay, now why they're storing this file in the bank? Maybe they store this file in S3 for backup. This might plan. This maybe they have planned, or maybe maybe they think S3 is a good storage. They give me a good availability. I already explained, guys, in initial classes. They give me a great durability. This data is very critical for me, so they give me guarantee. Whatever data I keep here, it never lose, or it will always be available whenever we need. This might be reason why they use S3. Okay, and let's say if this is the use case, all right, if they're looking for availability and the durability, of this data. Okay, and if S3 say S3 say this is my core core business of S3, I always give better durability and availability. Okay, because I have multiple different storage tab again. This is called storage classes here. I'll talk about guys in a minute what I'm talking about. Okay, so if you have a requirement, you want durability, availability, all of my types give you. Okay, but I am giving a lot of different types of the storage. Okay, and all the types will vary in the terms of cost. So if you as a bank, right, if you want to manage your costing also, right, so you have to properly plan which storage type or storage class you have to use. What I'm talking about in a minute, you understand what I'm talking about. Okay, so S3 say I have a lot of storage type available. Just for example, S3 say I have one storage type is known as standard, and this storage type is a super fast storage type. Okay, super fast, but I will charge a lot for this storage. But we have one more storage type called standard, right? For example, IA, it's called infrequent access type. So this is one of my type of S3. This is one of my type of S3. difference is this storage is again give you all the durability, availability. This storage also give you all the durability and availability of the data. The difference is this storage, let's say I charge you $100 for this or $100 for this. For this storage, maybe I will charge you $100. Okay. So as a bank or the company, obviously I will, because if both the guys are giving the same feature altogether, so I can plan better. I can store my storage in this type. Let me go for this one. So I will keep all of my file in this storage because they're giving me cheaper price. But if they're giving cheaper size, so what will be the difference? So again, guys, here the difference is IOPS. They say if you store the data here, okay, the way you can retrieve this data will be super faster. Okay, but if you store the data here, again, it's durable, it is available the way it is. Okay, but internally we have provided, it's not visible there. Okay, because it is managed managed services. Okay, but the speed of retrieving this object would be comparatively slow. Okay, so now you have to decide. Now you have to decide whatever data you're storing here. Does you require a powerful speed of IOPS or retrieving the data, or maybe that's in the time you can say speed or throughput or lesser. But if you think in a business use case, whatever data you're storing in a bucket, let's say bucket name is called bank bucket. Okay, you're storing all data. Let's say this is a third CSV file, fourth day CSV file, fifth day CSV file. Okay, per day we are storing here. And why I'm taking this example in this way per day, there's one reason for this. I will explain in a minute. Okay, so we're storing the data in this bucket. And for example, there might be possibility every week. Okay, my company will audit something. They will do some analysis every week or next Monday. What they do, they go back. For example, according to my calendar, next week is on 5th, let's say on 12th. So I go on 12th. Okay, and what I do, I wanted to do some reporting, some auditing, or some analysis, and for this I need data. So what a tool I want to use to analyze, I need the data obviously. So I go to this bucket, retrieve this data, and put this data in my tool, and I analyze. Okay, but this point in time, how faster you can read, that faster you can provide to your tool, that faster you can create a report. So it is okay for you if you read this data, right? For example, if you go for this one, it's okay for you if you read this data, let's say in 7 minutes. If you go for this one, if it's okay for you if you read the data in 1 minute. If that's my difference is okay for you, right, then you can go for this one. I'm just giving a very hypothetical number here. But if you think, no, I want a super fast speed, maybe there might possibility maybe I have a tool and who working on real time. So what the data is keep on coming today, my tool is keep on reading on the real time, and how quicker I can read, that much quicker real-time decision I can take. Because a lot of use cases we have, maybe some kind of fraud detection we have, right? So if fraud happen, my data is stored in my bucket in S3. Okay, my tool will keep on reading some AI tool we have. Okay, they keep on checking some cyber attacks. Okay, but if there's some delay in reading, it takes some minute, right? May fraud might happen. Because you see sometimes, some happen, if you do some transaction on credit card in some foreign countries, suddenly from bank you get a message, or suddenly from the bank you get a phone sometime. It is you who is doing this transaction. So they're super fast because they're using some tool who keep on using some AI to detect some kind of frauds. Okay, but for this they need data, but how faster they can get the data is always depend upon the hard disk speed. So if you have a requirement, you want data to be very quickly read, okay, then you can go for standard type of storage class OS3. Okay, and if you think it's a little bit slow speed is okay for you, then go for this one. So typically you can think another way. Normally in the company, all the data that they keep on using right now, they want quick speed right now, or maybe sometime all the latest data that whatever they have for today, for tomorrow, for 7 days, again, business to business, company to company vary what they treat as a latest data. For some company, 1 month data is latest. They keep on using every second 1 month data. For some company, last 1 hour data is latest. They keep on using last 1 hour data. Okay, so every company, this is very. So all the latest data I want to store in a storage that sometimes is also known as hot storage. So if you want to store data in hot storage, there is very frequently used data. If we want to store in the hot storage, is a simple term in the storage world. And if you talk about S3, do you provide any storage that will give me hot facility, right? Where I want to keep on reading my data very frequently. That is called standard type. So let me go to first storage page. It's called S3, and there's some more type they have of the storage, and that's called storage class. So what they do, guys, when you upload any data, so let me create one bucket here. Let's say A, B, C, 1, 2, 3, ER, some random bucket I'm creating here in Mumbai. Okay. So guys, while you're uploading your object here, you guys know in the S3 file is also known as object. And guys, one more time I want to give here, file is also known object and file is also known as key here. So when you heard this term key or file or object is the same thing in S3. So let me upload my key. Or I can say not in this way, when I upload any file, what a name you give to the file, that name is called key. That's the right way to say. So let me upload my one object or file and give this file a key. And by chance the file name is your key name. Okay. And while uploading, let me upload this file. Okay. That time, guys, if you go down, while uploading, in the last, in some additional options here, they give you storage classes. And they say, depend upon the design and the use cases. Use cases. Okay. So do you want to have a hotspot that will give you highest speed? And normally we use hotspot for frequently used data, for reporting and some other purpose, maybe. Go for standard. This will give you highest speed what is possible in our data center, but obviously it's come with a huge price. Okay. But I think now this data is not so much frequently, we can little bit delay, might be okay for us. And this data is a little bit infrequent access. So it's called IA. Okay. And typically, guys, in some normal storage world, it is also known as cold storage. So if you're looking for cold storage, means data is infrequently accessed, then you can go for this type. Otherwise, we have 5, 6 more types here. We'll discuss one by one. Okay. So this type, guys, we're talking about. So you want to go frequent data, just go for this one. And this is a by default type, by default type used in S3. Okay. Only thing is, they're not written here. Only thing is the price is very much high. Okay, very much high. That's the only difference. But the thing, your data would be very infrequent access, you can go for IA type, infrequent access type. Compared to this price, even though we go here, and comparative price of this guy would be very much cheaper than this. Okay, this is one thing. Okay, next thing here is, if you talk a little bit more about S3, if you talk more about S3, okay, so you know what happened, guys? Whenever you upload any file, and in the S3, we always select the region. So let's say I select the region Mumbai here right now. Okay, in my bucket. And when I select the Mumbai region, you know what it means? It means my file gonna store in the Mumbai AGs. And by default, guys, your file gonna store in all the AGs of Mumbai. Right now in Mumbai, we have 3 AG, but if we go to North Virginia, they have 6 AGs or 4 AGs, right, or 7 AGs. So by default, your file gonna store in Mumbai only, but in all the edges of the Mumbai. And obviously, guys, if you store in all the edges, some disaster happen here or here, your data will always be durable. If this goes down, your data will always available. And that is the reason, guys, they give you so much durability and availability in S3, because they replicate your data, copy data in all the edges in data center of Mumbai. And that's what they're talking about, guys. If you use standard, okay, they use all the edges, minimum 3 edges they use, but all the edges they're gonna use for this one. Same for IA also. They use all the edges. Okay, if you use this one. Okay, this is one thing. Okay, but obviously, because they're copying data in all the data centers, so they are investing their money in the storage. Obviously, they will charge you more. But if you think, if you think your data is not so much important, like it might be okay, some disaster happen, if this data center goes down or crash or something happen. Okay, very rarely obviously it's happen, but if think this might be okay for you, okay, but you have to save your time, so you save your money. Then you can tell the S3, I will upload a file. Okay, this file is first of all infrequent access. That's okay, but I don't want to store my data in all the edges. Just keep one AG, whatever you feel like. Okay, that's okay for me, because I want to save my money. So for these guys, you have to go for type called one zone A. Is infrequent access, but non-critical data. Okay, only one AZ they're going to use. But it will so very suddenly, guys, they lower down the price. Okay, and a lot of use cases we have. So you know something, this kind of use case normally we use in this area. So normally we have a database. Okay, and we create a copy of the database as a backup. Okay, in infrequent access. Okay, and normally the data is so critical, we always create one more secondary backup in zonal infrequent access. Okay, means we'll create a backup 2 times, one here and one here, as secondary backup or same data. Okay, due to this some reason, if this fail or this data center deleted, we have a backup here. Okay, but if you create backup 2 times here, obviously, guys, you have to give double cost. So this kind of planning, we keep the one backup here and one secondary backup, one more backup we keep here. Or maybe this very common use case. For example, you know, today, guys, we are if you guys are there in my AI workshop of AWS, I talking about we can use rack services, and they use some AI. They look on the images. Okay, we upload the image in S3, and I said this is images of the customer we uploaded. So because customer upload this image, and we know this image we don't want to use much. Okay, so we store this image in a IEA service, means infrequent access, because we don't want to use much, we want to save the money. But this image is very important. Maybe in the customer next in the future they want to use this image, so I should have a copy of the image provided by customer. Okay, but from this image, I use some AI techniques or image processing techniques, and I retrieve your face, crop the face, save this face in the new photograph, and so I can use this face somewhere. So new image come up. But guys, this image, actually image 2, let's say this image 1, image 2 come from image 1. By chance, any reason image 2 deleted or crash wherever they put in the data center, we can again create the same image from the first copy because we have the first copy available. So in this case, kind of use case, if you think second copy you created or thumbnail you created or crop image you created, if you delete it or data center crash, we can again create this. So this second image we can also put in one job. Okay, one job. In both the case, I considered both the image I don't want to use very frequently. Okay, so I store here. But if you think this image very frequently going to use, this is your company logo, every day you have to use, every time they have to use, then you can put in the storage. Okay, so this is the difference of the storage. So it's purely upon use case basis and purely upon the planning of your costing. And it's a huge cost difference, guys. It's not small. If you go, if we open the price, okay, and maybe somewhere you can see the price. So if you go for S3 standard, this much per GB the price. Okay, and if you go to infrequent access, this must price this they charge you. So it's a 0.01, 0.2. Okay, it's almost double. Okay, and if you go for zone 1, it is again 0.012, 0.01 is so much a difference. If you go talk about bigger size, a lot of data, this price matter a lot. Okay, and again, which guys is per region is vary. If you go to for example, if you go to North Virginia, okay, they have the same price here. If you go to Mumbai, price change, they're a little bit higher. If you go to Singapore, the price change. So they have a lot of regions, maybe coast management area, or maybe other region, maybe, but its price is based upon the region also. Okay. So this is one thing. Now, one more interesting thing here is normally if you talk about bank perspective, okay, it is normally a norms or they have a regulatory bodies. They say all the banking data maybe you're not useful, maybe this year and have done, but the banking data you have to retain may not be you when I'm going to use for next year or next year we're not going to use, but you have to retain for let's say 7 years. So this is a very basic term in the financial organization. So 7 year you have to retain your data. Okay, but this data not we're going to use next year or next year, but 7 year you have to keep is a regulatory body norms you have to follow. Okay, but this data very rarely some kind of audit happen, some kind of issue happen, so we have to retrieve this data maybe sometime, but not as a frequent basis, but rarely, we don't know, might be, might not be. Okay, so where so for this kind of storage I want to go for the cheapest solution, and obviously guys, if you go to cheapest solution, it will be the slowest one in the world. Okay, so guys, in the older world, okay, normal data center store data in the tab drives, and nowadays we don't use this, so it's become a absolute kind of things, and now this kind of storage is absolute, so now it's becoming cheaper. So the cloud over here, AWS, is providing you this storage, and they say because this is outdated, we have a lot of tab storage available, so we are selling you, providing you in the cheapest price. Okay, the only difference is they are so much slow. So much slow in something like this. If you store 1 GB data in S3 and if you want to access right now, within a second I give to you, millisecond I can give to you. But if you store 1 GB data in the tab drive, maybe it might take 2 hours, 4 hours, 2 days, 72 hours, depend. So that much time I might consume to retrieve this data. Because our use case is not frequent data. Rarely after 2 year, 3 year, maybe sometime we might have to read it, or maybe we don't have to read it. So, but we have to keep for some years. So to save the time, always, so we will save the money, obviously. So we can go for cheaper tab drives we can use. And for this, Amazon has a different service altogether known as Glacier. So Glacier is also, guys, as S3 service. This is also object storage. Okay. Only difference is S3 behind the scene using SSD with a powerful IOPS, higher speed, all the benefits they have in the terms of storage speed and performance. Glacier is again one service behind the scene. They're using the cheapest storage and hard disk in the world, uh, and they are willing providing us in the very cheap price. If I show you here, okay, if I show you here, you can see Glacier, okay, and you can see the difference. It is 0.5 per GB, and if you talk about S3, is 0.2. So big huge difference in the price. Okay, even though go for Glacier Deep also, they are more cheaper. So again, there are two different versions of Glacier, one normal Glacier, one Deep. Only difference is okay, they will retrieve your data in 1 to 12 hours. Okay, a lot of time they're gonna consume to retrieve your data. And Glacier Deep Archive is okay, it might take 12 hours or maybe more sometime to retrieve the data. And use cases, if you want to create a backup that rarely use, okay, you can go for this. Again, this is all for backup, also known as archiving, and rarely in a year or once you're going to use, then you go for this one. They're so slow. This is better than this, but the price is obviously very lower. Okay, so that guys, that's what guys the type is. So there are 4-5 types we have. One more type we have is called intelligent tiering. It is not actually storage. Okay, it is a combination of standard and infrequent and frequent. Okay, so if you store your data in intelligent tiering, okay, so they internally managing your costing automatically by checking your pattern. So if they find one object is very frequently using, keep on using. So to improve the performance, they automatically transfer the the file to S3 standard. But they find some of the file for some time is not using very frequently. So to save the money, they automatically internally transfer to infrequent access. Okay, so something like this, or maybe archive, or maybe maybe Glacier. So they shift for you. Okay, so there's the intelligent tiering. So they automatically check your pattern, and accordingly they try to manage your cost. Okay, so these are the types we have in the S3. So right now what I'm doing here, I'm uploading this file in let's say in the standard. But here guys, is standard. If you go to other storage, you have to give the guarantee that you have to keep your data for 30 days minimum. Okay, this much size you give, so some guarantee you have to give here. But in standard, there is no guarantee for minimum storage. Right now you store, right now delete, there's okay. But here minimum time you give the guarantee, otherwise they charge you that much. And there's one more called the reduced latency, is an older one. It's look like this one, but it is an older one. So nowadays, as such, we don't use this. So instead of this one, we use one zone IA. Okay. So what I'm doing here, I'm uploading the file in the Glacier. Okay. Initially, they had a different portal for the Glacier. If you see guys here and search for Glacier. Okay. So initially, guys, long back, they have a different page and landing page for the Glacier as a service, right? It looks something like this. Is a Glacier low cost storage service, right? There's some small difference here, guys. In the Glacier world, for example, S3, it is known as bucket. In Glacier, bucket and folder is known as vault. So that's what guys they're talking about. Do you want to create a vault? Okay, and in the let's say I'm going to create a vault called MyV, and next step, okay, there's this notification and submit. So the vault is created. Okay, but here guys, this is an older portal, but we don't have any options to upload the file here. So normally we use third-party tool actually as a client tool for Windows and NX, and we use this tool to upload the file and download the file in the Glacier. So this was the older portal. So as such, nowadays we don't use this. Now they merged both the portal in S3 only. Because here we can upload the file and download the file. That's what we are doing here. So this file I'm uploading here. But Intel in the Glacier perspective, they create instead of bucket, they use the term vault. But nowadays we use a bucket only. Okay, this is one small thing. So let me upload this file in the Glacier. So that's all guys uploaded. But now because I uploaded the Glacier, okay, and now if you want to see a Glacier and you want to download this file, okay, it's going to take a lot of time. For example, let me upload one more time, one more file, and I'm uploading this file, or let's say this file. Okay, and by default, the uploading in the let me go for same standard one. This is by default, and I upload this file in S3. Okay, because they upload in the standard S3, they're super fast. Obviously, they charge more. So if I click here, and here they give me option to directly open, means download or download also. So if I click open, so it will open for me or download for me quickly with the speed of my internet, whatever I have. But their way of reading it is super fast. But if you try to download this file, this one does in the Glacier. Okay, you guys here we don't have any options to open and download. They don't give this option. Okay, because they say it is there in my tab drive, and I told you already it takes a lot of time to download. Okay, so this object is stored in the Glacier. If you want to download, you have to first restore it. Means you're sending the instruction to somebody. You can think in this way, and they somebody or maybe some human being, some robot or some program go and find this thing for you and retrieve for you. Then you can download. Okay, so you have to send an initiation request that you want to restore this file in the Glacier. Okay, if you click here, then here they ask you the 3 type of retrievals. Okay, one is called bulk, standard, expedite. Okay, so you want your retrievals to be faster. Maybe you have certain requirement. Maybe this is a 7-year-old data in your Glacier, and suddenly auditing company want this data to be out now within a minute. You can go for expedite retrieval. And if you want data will come within a 45 hours, go for this one. If you think there's okay, maybe next day I get the data, go for this one. Okay, so they retrieve this data. Obviously, if you go for this one, they will charge you more. If you go for this one, they will charge you more. And this time, guys, this is the first time you might see, okay, in storage world, they also charge you a fee of retrieval. Charging of storage is different, but retrieval fees is also different. So in the Glacier world, they will charge you for the retrieval fees. Okay, and how much they charge depend upon what speed you want to retrieve. But technically, when you retrieve, they store in some temporary location, or let's say they store in some S3. So they ask you how much time you want to store. Okay, so let me say for 1 day. So they keep this data for 1 day. At this point, they will delete your data finally. Again, you want to use this again, they will again retrieve. Okay, so let me retrieve this with expedite within a minute. This will come up. Okay, and initial retrieve. So now my retrieval process started. Even though I can read it because this process in progress. In 105 minutes, my retrieval complete. Then you can go and open and download this program. Okay, so that's what guys in the Glacier we have to think about, know about. Okay, so so now we have, guys, this is a very common thing. If you go to interviews also, if you go to examiners also, this is a very common thing. They ask you how many storage type we have. So technically in ABS, a lot of storage type we have for different use cases. S3 a lot of type we have, also known as classes, storage classes. Somewhere they might write. So a lot of storage classes you have, or maybe if I search S3 storage classes, and here they show you details of this classes. Okay, so these are classes, guys, I have a talk about, and I think they also give you a very interesting table over here. Yeah, this one. Okay, so there's a big difference over here. So if you talk about availability, you go to anywhere, availability is almost same. If you go to durability, is almost same. Okay, only difference is okay, fees. Okay, and the transfer speed and how much faster they retrieve. It might take hours, it might take minutes. They are milli fast. millisecond retrieval times, right? So this is the only difference. Otherwise, S3 is designed for durability and availability. What is durability, availability? We have already discussed. But based on use case to use case, so if you want to store some hot data, frequently used data, go for standard. You have to pay more. Less frequently used data, but you want to retrieve within a millisecond only, then go for this one. There is not so much critical. Okay, go for this one. That's the reason, guys. They say in one zone, sorry, they say your availability is less here. It's very less compared to this one. Of availability, right? And this one, and accordingly you can plan your storage classes. Okay, so that's what here. So I think, guys, this process it might have done. Okay. So, but here, if you notice here, this process is very much manual. Manual means you have to manually go first, select standard, and you think this file is not so much useful. Useful. I want to giving the price of this this much storage, so I can go back and there's option to change the storage class. I can go and change the storage class to this one and save it. So what happened, guys? Your data move from standard to infrequent access. Okay, now from onwards, you will data will be there, but you have to pay less. Okay, so right now I'm doing it manually, transferring my storage from here and there, but we have millions of files in the organization. Transferring this file from here and there manually is always a very tedious task. And guys, here the role of life cycle come into. Okay, so we ask the life cycle, they will do this thing automatic for me. So life cycle, guys, pretty simple, but I will want to discuss this point in the next class. Let me show you this point only as the last. So my initiator, I think, is done, completed faster because I used expedited retrieval. And now this option, guys, come up. We can open, we can download all the things we can do here. Okay. So that's what. So these are different type of storage. And we have some more discussion to be done on the performance of S3, like multi-part upload, acceleration, and S3 glacier select, okay, or life cycle, and some more small thing. One interesting is prefix key, a very interesting concept, very much useful in big data world also, okay, because we use S3 for big data normally. So next class, guys, we will talk about this topic. Okay, but I think you got the idea overall. In terms of capacity cost planning, you have to plan it according to use case, which storage to use and which type to use. So that is the main point to understand. Okay, so that's all for today, guys. For today, any point if you have to discuss, you can discuss to me. Very interesting question actually asked by Kalyani. Why we need S3 for big data? Because normally we store big data in Hadoop, but technically Hadoop is just a program. Hadoop need a hard disk. Who give the hard disk to Hadoop? EBS is the one who gives hard disk to Hadoop. Okay, so Kalyani, your question is very right, but Hadoop is just a program. MR is a service here in AWS to create the Hadoop for you, but whenever you create a data node in the Hadoop, they require hard disk. From where I get the hard disk? From EBS. Which type of hard disk I get? Depending on my use case. Here I can go for ST1 type of hard disk. No, bursting concept as such, we don't have an S3 regulation. Even though we can't see the IO also everything here, it has been hidden. Everything is abstracted. Okay, so they don't provide you as such the credit or bursting concept. It is there in other services also, but in EBS we discuss. How to host the page in S3? Yes, I think we'll discuss in the upcoming class how to host a website on S3. It's called a static website. No, on card, I know S3 and data migration service there. We'll discuss, don't worry. At least listen once, please listen to me. So with actually what technically you're talking about, I haven't seen your any text because text here come randomly. Okay, so I don't know what message you have. So no, throughput and IOPS is not same actually. Thing IOPS is a unit to check how many random operations you can do on the hard disk. Okay. Throughput is normally not always normally on the storage to check if you're reading as data, what is speed you have in normally in the continuous data, not random, continuous data. Normally you can think of the difference, but in random also we can find the throughput at a different point. But throughput normally is a measure and check the speed, or it is unit to tell if your data is continuous, what the speed you can read and write, especially read. So that's okay, guys. I believe a lot of guys asking the query that is not actually part of this program, like Cryo and Docker, other thing Azure. Okay, so just try to guys practice till here. A lot of information I give to you. As such, there is no so much practice for today, but this information is is very much important for properly planning the things, right? That's all, guys, for today. And see you guys in the next class. Bye. Take care.